Okay, so this is a continuation of the last video on rank. That video was getting a little bit on the long side, so I decided to truncate things. We finished the last video by tackling this matrix here and working out the rank for this matrix and working out the solutions. We found that both the coefficient matrix and the augmented matrix had rank 2, and we wrote down the solution. We found that, the rank was 2. There are 3 variables, so we have 1 free variable left over. 3 minus 2 gives us 1 free variable, and we wrote down the general solution. This second one, I'm going to leave this as an exercise so that we can jump to another possibly more interesting example. So in this video, I just want to focus on this example here. This is one that perhaps might be viewed as more challenging because you can see that, all right, there are some undetermined values in the matrix. There's an A and there's a B and they're unknown, and we want to know for what values of A and B does the system have a solution, and if it does it have a unique solution, or does it have infinitely many? So let's play around with this and see what we can do. Now, A and B are unknown, but that doesn't change the fact that we've got an algorithm for deciding these sorts of problems. How do we decide these sorts of problems? Well, we start doing row operations to simplify. So we look at our matrix, we say, okay, got my first leading one. What do I do with my leading one? I use it to create zeros. So what are our first operations? Our first operations are going to be to take row 2 minus 2 row 1 and make that my new row 2, and take row 3 minus 3 row 1 and make that my new row 3. So doing that, where do we get to? 1 minus 2, 1, 4. We left the first row alone. So I get 0 minus 1 plus 4, 3. Okay. 5 minus 2 is 3. 2 minus 8 gives me minus 6. 3 minus 3, 0. 0 subtract minus 3, or 0 minus 3 times minus 2, so that's 0 plus 6. I get a 6. And then here I get, well, it's A minus 3 times 1. I get A minus 3. In the constants column, B minus 3 times 4 gets me B minus 12. Okay. All right, how do we get our second leading one? Well, the only thing we can really do is multiply one of these rows by a constant. And row 2 is a good candidate. Everything's a multiple of 3, so we do 1 over 3 row 2. Make that my new row 2. 1 minus 2, 1, 4, 0, 1, 1, minus 2, 0, 6, A minus 3, B minus 12. Okay, second leading one is in place. What are we going to do? We're going to use it to get rid of that 6. So we're going to do row 3 minus 6 row 2. We're going to make that the new row 3. 1 minus 2, 1, 4, 0, 1, 1 minus 2, 0, 0. So A minus 3 minus 6 more gives me A minus 9. B minus 12 minus 6 times minus 2, that's B minus 12 plus 12. 12s cancel and get me down to there. Okay, well, now we can see that there are a couple of possibilities here, right? So if this is, if this is our coefficient matrix, so this guy here is okay, if this is A, we can see that the rank of A, well, it's going to be either 2 or 3 depending on the value of A. How do I get rank 2? Well, if A is equal to 9, I've got a 0 in the third row, third column, and I don't get my leading one. If A has any value other than 9, then A minus 9 is a non-zero value, and I can divide row 3 by A minus 9 and get a leading one there. Right? So if A is not equal to 9, I can create a leading one in this spot, and I'll have rank 3. Okay, and so now we can see that there are three cases, right? Well, the first one, if A is not equal to 9, then we've got a leading one. We'll get a leading one in each one of the columns, and then we know we've got a unique solution, right? Doesn't matter what B is. As long as A is not equal to 9, I've got a leading one in each one of the variables columns, and I'm guaranteed a unique solution, right? The rank is maximum in that case. If A is equal to 9, then the rank of A is equal to 2, and then we know we've got two possibilities. So if A is equal to 9, rank of the coefficient matrix is equal to 2, right? We know then there's two possibilities. The rank of the whole thing of the augmented matrix is also 2, or the rank of the augmented matrix could be 3. If B is not equal to 0, right, then the augmented matrix would have rank 3, coefficient matrix has rank only 2, and that means that there is no solution at all. The last possibility, if A is 9 and B is equal to 0, well, then the augmented matrix has rank 2 as well as the coefficient matrix. So the rank would be 2, the number of variables would be 3, so there would be 3 minus 2, which is 1 free variable, and we know that we would have infinitely many solutions. In fact, we can say what they would be in that case, right? If A is 9, B is equal to 0, then I end up with one more row operation. I would end up with, so if I added 2 times row 2 to row 1, I would get 1, 0, 3, 0, 0, 1, 1, minus 2. So this is the R reduced row echelon form for A equals 9, B equals 0, and we could see that the solution in that case, x would be equal to minus 3z, y would be minus 2 minus z, z would be free, right? So we could write down the solution in that case. Okay, so that's this additional example I wanted to do for rank. We've got one more topic and then we'll be done with systems.